Hello, this is Mr. Huber. In this lesson, we're going to look at graphing using intercepts. Okay? If you have any 2 points anywhere, you can draw a line through them. I don't care where you put 2 points, there's a line that would go through those 2 points. So the way we can graph a line sometimes can be done by using 2 points known as the intercepts. Okay? So if we can find where those two intercepts are, we can draw a line that goes through them, and that line would be the one that goes through those points and all the other ones that are on that particular line. So how do we find the intercepts, and what are they? Right? The intercepts are the points where the line would cross each axis. Okay? So a y-intercept is the point where the line crosses the y-axis. The x-intercept is the point where the graph crosses the x-axis. So let's see what that looks like in a graph here. Right? Y-intercept and x-intercept. Okay? The y-intercept is the point where the graph crosses the y-axis. That would be this point right here. This would be the y-intercept for this particular line. That's the point where we're crossing the y-axis. Then the line goes through and it hits the x-axis. This would be the point where the graph crosses the x-axis. This is known as the x-intercept. Okay, so y-intercept where it crosses the y-axis, x-intercept where it crosses the x-axis. And let's look at what we might notice about the coordinates for each of these intercepts. This y-intercept is 0, 6. The x-intercept is 3, 0. You're going to notice a 0 in place of the other coordinate. So in the y-intercept, y value of 6 in this case, the x value would be 0. In the x-intercept, we have an x value of 3 and a y value of 0. Any point on the x-axis will have a y value of 0. This would be 1, 0, 2, 0, 3, 0, 4, 0, so on. So it would always be 0. The y-intercept will always be 0, something, 0, 1, 0, 2, 0, 3, 0, 4. So the y-intercept will always have an x value of 0. The x-intercept will always have a y value of 0. So when we see an equation, we can find the intercept by plugging 0 in for the other value. So to find a y-intercept, we can substitute 0 in for x. That would be the value of y when x is 0, right? This is the value for y when x is 0. And to find the x-intercept, we plug a 0 in for y, right? That would give us the x-intercept. We put a 0 in for y. We'll find out what x is. That would be the x-intercept when y is 0. So the y-intercept will always have an x value of 0. The x-intercept will always have a y value of 0. Let's see how we could use that. If we want to graph this equation, 4x minus 3y equals 24. So if we want to graph this, we can find the x-intercept and the y-intercept. We could find the x-intercept because y is equal to 0 at that point. So we'll have 4x minus 3 times 0 equals 24. 3 times 0 is just 0. So that will cancel out. We'll just have 4x equals 24. And when I divide both sides by 4, I get x equals 6. So my x-intercept would be 6, 0. X value 6, y value of 0. Right? When my y was 0, my x was 6. Those would be an ordered pair. 6, 0, that'd be the point right there. And then if I want to find the x-intercept, or excuse me, the y-intercept, we just found the x-intercept. So the y-intercept is going to be when x is equal to 0. So I'm going to have 4 times 0 minus 3y equals 24. Right? That will cancel out. 4 times 0 is just 0 minus 3y, so I'm going to divide by negative 3, and I'll get y equals negative 8. So I would have the point 0, negative 8. X value of 0, y value of negative 8. So I could graph that point, 0, negative 8, or I cross the y-axis. So my x-intercept has an x value of 6 right here. That's 6, 0. 0, negative 8, the y-intercept, and then I could draw a line through those 2 points. So my graph would be a line that goes through those 2 points. Okay? Anytime I have 2 points, I can draw a line through them. And if I could find those intercepts, those will be 2 points I could use to show what the graph for this equation would look like. So that would be the graph for this equation right here. Using the intercept. Plug a 0 in for one value to find the other intercept. Let's try another one. And again, you should try this. Pause the video, try it out, see if you can find the two intercepts, and we'll draw the graph. So if we're going to find the x and y-intercept, it doesn't matter what order you find them in. Okay, let's find the y-intercept first this time. Last time we found the x-intercept first. It doesn't really matter. The y-intercept has an x value of 0. So when the x value is 0, negative 2 times 0 plus 5y equals 20. Right? Negative 2 times 0 is just 0. So we're going to have 5y equals 20, and divide by 5 on both sides. We get y equals 4. So we're going to have the point 0, comma 4. 0, comma 4, point right there. Okay. Now I want to find the x-intercept. So the x-intercept will have a y value of 0. So negative 2x plus 5 times 0 equals negative 20. Again, that will cancel out, and I can divide by negative 2 on both sides to find that x equals 10. So x equals 10. So we'll point right out here where x equals 10. And then I could draw my line through those 2 points. So I can draw a line that goes through those 2 points. And I've got my graph for that equation using the 2 intercepts. So plug in a 0 for x to find the y-intercept, plug in a 0 for y to find the x-intercept, know what that gives you, where those 2 coordinates are in terms of the y-intercept crossing the y-axis, the x-intercept crossing the x-axis. You got 2 points, and you draw a line through those 2 points. Let's look at a couple graphs that are drawn for us now and determine what the x and y-intercepts would be. So if we look at this first graph, right, we go here, we got the intercepts right here and right here. Okay, so the x-intercept, make sure we know which one that is. That's where it crosses the x-axis. So that's my point right here. The x-intercept will always have a y value of 0, which we can see there, right? It's 2, comma 0. And the y-intercept would be 0, comma negative 1. Right, this point right here, 0, comma negative 1. So I've got my 2 intercepts, x-intercept, y-intercept. All right, you look at the next graph, see if you can determine what the intercepts are for this particular graph. All right, on this problem, the x-intercept will be where it crosses the x-axis. That's right out here. So we're going to go over 1, 2, 3, 4 to the left. So that's negative 4. Right? So I'm going to have negative 4, comma 0. And the y-intercept, I go up 2 on the y-axis. So 0, comma 2. And you notice x-intercept is some x value where it crosses the x-axis, comma 0. Right? X-intercept, y value of 0. Y-intercept, x value of 0. So we can read those intercepts from a graph, just like we use the graph, or use the intercepts to draw a graph. So I just said some basic math. What we needed at this point? Yes. I think that's very true, right? We got to have enough bacon for 2 people. Make the packages bigger. Let's eat it up. All right, moving on. Let's do an application of some intercepts here. All right, you're helping to plan an awards banquet for the school, and we need to seat 180 people who are going to be coming. We can have 2 different sizes tables. Okay, it tells us small tables here seat 4 people. Large tables seat 6 people. So 2 different size tables. This situation can be modeled by the equation we've got here, right? 4 times s. However many small tables we rent times 4. Right? So if we rent 5 small tables, we can seat 4 at each of them. 4 times 5, they give us 20 people that can sit. Right? S is the small tables. Then 6 at each large table. So again, if we rented 5 large tables, 6 times 5, they give us 30. We could seat 30 people at those large tables. We need to seat 180, so we need some combination of small and large tables that will give us 180 seats. We don't want to have 100 seats or 240 seats. We want to have the right number of seats for the people coming, for 180 people. We can use the intercepts to graph this situation. Right? So we can use the intercepts here by plugging, it's not x and y, that's okay. We can use s and l. Right? You could use x and y as well. I just want to use different letters here so we see it's not always dependent on it being an x and a y. Okay? So it says the x and y intercept, this would be the s and l intercepts. And it doesn't matter which one you put on which axis. That's why I kind of kept it as x and y here. Right? We could call the s the x-axis, the l the y-axis, or the other way around. It doesn't matter. But we can find the intercepts and graph this situation. So to find the, and I'll change it down here, to find the s-intercept, we're going to have a l value of 0. Okay? So we take our equation. We have 4s plus 6 times 0 equals 180. Right? This cancels out, and we'll have 4s equals 180. Divide by 4 on both sides, and we could get s equals 45. Okay, so when there's 0 large tables, we need 45 small tables to seat all the people. Right? So now the next one, let's call this the L-intercept, would have an s of 0. So if we have 0 small tables, how many large tables? So we have 4 times 0 plus 6L equals 180. And that cancels out. We get 6L equals 180 divided by 6 on both sides. We get L equals 30. Okay, so these intercepts are saying S-intercept is when I had L0. So when I have 0 large tables, I'd need 45 small tables to be able to seat 180 people. If I have 0 small tables, I need 30 large tables. Okay, so let's see what that looks like on our graph. Let's label our graph as well. So we're going to have the, I would call that the S-axis and the vertical the L-axis. You could switch them. It's fine. Okay. And I'm going to go by 5s on each axis. Okay. So we've got that axis labeled, and I'll go with 5s on this one as well. Okay. So I've got each of my axes labeled now, and I'm going to graph on them. So my S-intercept is at 45, right? My S-intercept here at 45. So when L is 0, my S-axis, I'm going to go over to 45, and I have a point right there, 45. Okay? Then my L-intercept is 30. That'd be the point right here, where S is 0. Right? So I've got my two intercepts on the S-axis at 45, on the L-axis at 30. Okay? And again, you could switch them. If you want to put L down here, then your intercept would be at 30. S up this way would be at 45. That's fine. It doesn't matter which one you are using as your horizontal and your vertical axes in this case. And I'm going to draw a graph through these points. So when I draw my graph through these points, okay, we're going to stop at each point. We're just going to draw a graph that goes from one point to the other. It's not going to extend past there. We can't have some kind of negative tables or anything else. We know our two intercepts, and how did that help us? Well, every other point on that line is also a combination of numbers of tables that would work for this situation. Remember, the graph is all of the points that are solutions to the equation. So these are all points that would solve this equation. This whole graph is points that would solve this equation. One of our questions here after we got the intercepts and graphed it, okay, so we got the intercepts, graphed the equation. Now we want to give 3 possibilities for the numbers of each size of table you could rent. So we want to find 3 combinations of different numbers of tables. So one thing we could do here is use our intercepts, right? Let's do that. We've already done the work on those. So we could have S equals 0, L equals 30. That's one combination of tables that we could use. We have 0 small tables, 30 large tables. Or we could have S equals 45 when L equals 0. That is also a combination of tables. And then we could use our graph to get close to, right? I drew it by hand, so it's not going to be exact, but we could figure out maybe what happens when S or L are some other different number of tables. So for instance, 10 large tables. Let's see what happens when if I get 10 large tables, how many small tables that would be. So I need to go back to my equation now. I'm going to have 4S plus 6 times 10. I want to see what happens when the L is 10. Okay, so I'm going to have 4S plus 60. Sorry, my S kind of turned into a 8 there. That's 4S. Okay, 4S plus 60 equals 180. And then I could subtract the 60 on both sides. Okay, when I do that, I'm going to give myself a little room there. So I got 4S equals 120, and I divide by 4. I get S equals 30. So when S is 30, L was 10, that's a combination of tables that would be a solution for this equation. We can look at that. When L was 10, S 30, even by drawing my graph by hand, I got a pretty good idea. So any of these points, whatever this combination of small and large tables is, should be a solution. Whatever this combination is right here should be a solution. So we might have to test it out, right? You can't just pick any numbers you want, but we've got 2 from our intercepts, and we have a third possibility here based on, we use our graph to get an idea of what might work, and then we need to plug a number in and make sure that we've got a combination of small and large tables in this situation that'll seat our 180 people. So remember, the intercepts are the values when the other variable's value is equal to 0. You can use x and y, s and l, it doesn't matter. To find an intercept, you put a 0 in for the other variable. So when we talk about x and y's, to find the x-intercept, put a y in for 0. When we find the y-intercept, the x value is 0. Remember, those are the points where the graph crosses each axis. And then we can use that to draw a graph. We can read those from graphs. In a situation like this, it can help us figure out what might work for a situation where we're trying to figure out combinations of the number of tables or anything else. You can put in a 0, you can find the other value that goes with that.